Okay, so that was flow statistics. Flow statistics. Okay, so let's talk more about outputting data. I'm going to go through a variety of mechanisms. Uh, convenient mechanisms to periodically output data using events. We've just done that. With an event, we periodically report at certain intervals the state of things, flow statistics, stock statistics, summaries of the current population, and if differences. And I noted the need to save information in the context of run. Okay, I've asked you to, but I think we're going to skip this. I'm just going to show you some things. One thing is this whole graphing that goes on. That's a very useful sort of element. Incidentally, this is okay. This is a very nice little thing we can do. Click on a variable, see its graph over time. Although we have to do that, we have to click at that little graph thing up there. We can also, I didn't show you this, but you might want to try it yourself. If we have a graph like that, so if we're running this, you can actually right-click on the graph, this sort of custom graph that you've created. See this? You can right-click on it, and here's this data coming out. We could do a graph of it. Okay, so it's coming out here, and now we can right-click on this and do copy, and we could go over to Excel, for example, and we can paste it in. What are these things to the left, and what are these things on the right? What do you think? It's the time and the value. So here, with these custom graphs, we're not necessarily getting everything on our reporting interval. Instead, we're just getting it at certain periods of time. Okay, and we can plot those sort of things in a variety of ways, including like a scatter plot in Excel. This is it accumulating over time. Okay, so let's go here. So you can paste it Excel, press the stop button to stop it. Okay. So these are sort of ad hoc exports from variables we've been looking at. The mechanisms on the system dynamics side are particularly rich in this regard. All these variables accumulate values, but if you have variables here that are exposed to be seen at runtime, you can do this with respect to them. Okay. Let's talk about pre-prepared methods, though. One of the most common ones is defining statistics, and we've seen how that's done, so I'm not going to go into that again. We've done quite a bit of that. The statistics can be defined at multiple levels, as we saw this morning, and we can interrogate them sort of while the model's running in a fruitful way. We can also, we've also defined time plots. We've seen that already. And one notable thing is you can right-click on a time plot, and you can use that time plot to export the data to Excel. Okay, so time plots are useful in that regard. One of the most important things to be aware of here is data sets. Okay, we haven't defined data sets for our models, but we could. And just to show you how this works, what I'd like to do is to actually define a data set associated with these flow variables that we're creating. So specifically within this canvas, I'd like you to drag this down until you can find data set. Okay, see this data set here? And I'd like to drag over data set into this model. So this is this SIR model. So this will be called Dataset new infections, new weekly infections. Okay. I'm not going to rely on the names, but well, actually, sorry, I will. I guess Dataset new weekly infections. To put it up on the big screen, what we have is this Dataset new weekly infections. Okay. Is that okay? Okay. So what we're going to do is to periodically sample in the data set um, from this value here. Excuse me. Okay, we could do this two ways. In fact, I think I'm going to show you these two ways, I'm going to create another data set as well. This will be called Dataset current infections. Okay, that'll be a stock variable, so to speak. It summarizes the result at the current time. Dataset new weekly infections will be a flow variable. It summarizes the number that have occurred since the last time. Okay, so let's do the current infections first. I could have called it prevalent cases if I had been purely with a health audience. I probably would have called it prevalent cases. Okay, so dataset current infections. For the vertical axis value, I'd like this to be, well, what are we going to use for the current vertical value? Well, current value for it. We're going to use n infectious. That's the variable that AnyLogic uses to display this information up here. Okay, n infectious. Okay, so this data set is going to have as its value n infectious, and I'd like it to update the data automatically, and I'd like to keep as many samples as we need. So I'm just going to put 10,000 latest samples. So here's updating it periodically, updating it with a recurrence time of 1. It's going to be accumulating this value, okay? So in short, I've defined a data set that depends on this variable n infectious here, and it's going to be sampling it every time unit and just getting its value, okay? Although I think I'll make it a recurrence time of 7 just to make it weekly. So it'll be accumulated at a weekly interval. Okay? You mean like because it was 1? Actually, it's actually 1.0. It was actually originally, they just put it there as the default, putting it as 1. I could have gone from 7. Why I didn't phrase it like that, I could have. I thought I'd do that just to communicate this is in fact a double number. It could be separated by 0.5 or 0.2 or whatever. Okay? Does this make sense to people? Now we're sampling that. Okay, so let's run this model. Okay, let's get over to that data set. Okay, this is the only one that's accumulating now. Let's click on it. Here's the data in the data set. These are these periodically sampled values that are being sampled from the count of people infected. We saw before how these could be turned into a graph, and we can, and in general, we can copy them and paste them to external programs like Excel or R. Okay, R is a nice facility for dealing with clipboard data. So in any case, these are values of the data set over time. It looks like maybe the graphing is disabled for this guy for interesting reasons. Of course, we can also interact with the variable on which it's based. But a data set will afford us some extra advantages, such as the capacity to export it to a file easily. So we're going to come back to this. Okay, now I showed you one type of data set, but another common type that you'll need is one which can't be just sampled regularly from a value. Instead, we have to insert into it manually. So let's go do that one. Okay. So for that data set, we want to every week insert into this data set the new cases of infection over the past week. Where would I go to do that? Can you tell me? If we want to insert it to this data, the same data we were printing out, which is the number of new infections in the past week, where do we do that? In the event. It's in the event. That's right. And we would insert into it this thing here, right? Now I have a secret agenda here. It's the agenda that my colleague in Assad Al-Azam calls contaminating minds. which is I'm contaminating you with computer science ideas. Um, so so let's rehearse how to do that, and then how to do it badly, and then rehearse how to do it well. Okay, and that will be the contamination. How to do it well. I consider it helping to purify your minds personally, but or at least to expand them. Okay, so let's do it badly. Okay, I want to accumulate this in the data set. How do you think I'll do that in Java? Sorry? Okay, so we'll do actually data set. The data set, and what is it called? Data set new weekly infections. And then actually we do add. Okay? Add. See it, and it says add a new data item. This method is supported only with data sets with enabled use time as horizontal axis value. That's what we have. So we're going to add in, and I'm going to add this value here that I put here, okay? There. I'm going to add that value. That's the difference, right? This is the difference. This is the number that have come in the past week. But I think this is abusive. If I look at this, this is not a good practice. This is a bad practice. You'll see it a lot, but it's bad practice. Look, we have the same, so imagine someone coming to your code, perhaps yourself before this week, perhaps yourself tomorrow, looking at that code, especially from the distance with which you are currently beset, and trying to understand that code. You will see, gosh, it's I apologize, it's so small. But you will see this difference here, and then you'll see something that kind of looks like it, and you got to kind of study it and figure, okay, is it the same difference, and what does that difference mean? And you kind of got to go back and recreate in your thinking, where did that come from? What does it mean? Don't do that, folks. Give it a name. Make it clear to people. Give it a name that's clear. So you will have here int, you'll introduce a little variable. It'll be, int new, count new infections, and make that equal to the difference between them. And then you'll use that, just refer to that variable this place and refer to it here. This has two advantages. First of all, it communicates very clearly by giving us count new infections. When you read this, you know exactly what this means. You don't have to sweat it. Okay, it's meant to be the count of new infections. Okay, and secondly, you've eliminated the clutter. I mean, you're referring to the same variable twice instead of referring to this complicated expression. It's not even clear visually if it is the same expression. Maybe there's a slight difference in spelling. So name things clearly. Give it, communicate your meaning. That's important. It saves you headaches down the road. It saves other people headaches. It lowers the risk of error. So here, all we've done this, and I'm also trying to teach you, it's in your interest to declare variables. This is nothing scary. You're just creating a variable that refers to this difference. It's a name for that difference, and it stores that difference as of this point, and then it uses it in two places. So here we have ultimately what is clear code. We have this defined, and then we're going to print it out, and then we're going to add it to that data set. Does that make sense to people? Okay, I'm sorry. So I'll put this up on the big screen here. The problem is these things are too long to fit neatly in it. This is what's up there, and it's wrapping around, unfortunately. But I'll see if I can make it a little bit smaller, and maybe it'll fit a little bit better. This is probably sorry. This is what it is here. Can you read that? Is that better? Okay. So all this is it was the expression that was there before. This new one minus the old one, and I just gave it a new name, count new infections, and then I just used that in two places. The new line I put in was this one. We're adding this to the data set. We're adding it to the data set because we want the data set to have that new value, each successive value. Does that make sense to people? Are people comfortable with that? You can. Data sets can. Okay, so I'm trying to unpack your question. If what you're asking is, can you have a data set store over time more than one variable? The answer is no. You need a couple data sets, which is fine. There are things called phase data sets, and they store successive pairs of two different variables. But that probably isn't what you're looking for either. But there are those sort of data sets, but they won't store the time associated with it, with the sample. Okay. Okay. Does this make sense to people? What I'm doing here? Okay. So here the difference here is that we're manually adding in this new value to the data set, okay? And we do that because, okay, oh, look at that. It's complaining. Oh, darn it. Sorry, folks, I should have compiled. I said int instead of double. This should have been double count new infections. Oh, sorry. Oh my gosh. Wait a minute. It should be an int. Gosh. Oh no, don't tell me. These variables, are they doubles? Oh gosh. Okay, I've been contaminating your minds in a true sense. Okay, there we go. These should be int variables. Why are they ints? Who could tell me? Because they hold an integer, a count. 0, 1, 2, 3, 4, 5. Now, integers only go up to a certain point, but I think it's around 4 billion. Actually, I think it may be 2 to the 31 minus 1, so it's around 2 billion. They go from about minus 2 billion to plus 2 billion. And for our model here, it's enough. Occasionally we'll use longs instead, long values, which can store up to the square of that. Okay. So Mike, I had this is an int, but we changed these values to each be ints. Okay. Okay. So here we should be able to run this, and we should have these things accumulated over here. So here we have 10 samples of this, 10 samples of that. You see that? We have these samples accumulated in each of those data sets. So what I've just displayed for you is how you calculate, how you include data sets, which include both automatic updates and manual updates. And to answer the gentleman's question back there, here we have two different data sets. They're sampled at the same points, but they're accumulated in two different data sets, these two different variables. Questions about this, about data sets? Data set? Okay. So data sets will be one of your keys for accumulating values. Now, there's a variety of options you have for data. They can, as we've seen, be updated automatically or manually. Be sure to consider the fact that they have a limited number of samples they support. So if you're accumulating a large number of samples, be sure to make sure you fill in this, keep up to 5,000 latest samples. Okay. With system dynamics values like stocks and flows, you'll note that they automatically include accumulated the capacity for displaying their data, and you can display graphs of them over time. Okay, from a manual perspective, data sets are very handy. We can copy them, for example, to spreadsheets very simply. And there's a variety of types of data sets. Some data sets hold histograms, for example. Those are useful. Others hold the pairs of values, times, and then there's ones that hold values only. Okay, we've talked about output to console before, so I'm not going to beat this dead horse. But we can output things using trace ln is a common thing. You may want to consider using some additional mechanisms. For example, you can output things in different colors. So by doing system.error.println, it can highlight certain things that are of particular concern or notable in a red color as to a black. This has some advantages to it. It's readily visible. You can copy and paste. The cons is it's awfully easy to get it mixed up with other output. It's of limited length. It depends on your memory to copy it, and it's less structured. Okay, AnyLogic provides a variety of mechanisms for outputting data. We've made use of a variety of mechanisms in different models, and some of them have made use of the built-in mechanisms and sometimes not. You'll notice that there's the capacity here to output to a text file. So AnyLogic provides this text file connectivity, and you can specify the separators for the file. For example, do you want it to be tab separated, comma separated, a CSV file, space separated, etc. And you can use this actually for reading or for writing. You can actually append to it as well. The separator specification is used for the reading. And you can specify a file to which you want to output. Once you've done that, you have that sort of mechanism. Then if you have a reporting event within your the file here, you can call off to that object, and you can print to it. So you can print values, in short, to a file by calling println on that object. If you're using it for input, there's a wide variety of things to read data from that text file, but otherwise you probably want to print to that text file. With a file, if you specify a file name, Sydney output.txt, something along those lines, we could then have the weekly reporting event write to that file. So println, and it could print out the count of new infections, for example. And that would be printed on each successive line of that file. Okay. There's additional capacity to close a file. So once a file is finished, it's good practice to close it to make sure that it's not left hanging, that all the data is properly written to it. And you might want to do that in the destroy code of your main class. So that's one of these events that it sort of cleans up after itself. Hence, it's there. So here, associated with this event, we printed a value to this file, and that will allow us to persist these values. So I'm going to run this here, and as this is spreading, it's outputting to this console to be sure, but it's also now outputting to a file that's located in a place that I specified here. I apologize that have you do this along with me. It's just that time is very short here, and if I go look, I can find that, and oh, okay, so that's interesting. I was expecting data as part of that. I'll have to check what's going on. But here we have successive prints to it, and we should be able to accumulate data here. I'm just looking if I missed an element of this. No. Okay, so that shows one way to print to files. There's an additional way that I show here, whereby I can refer to a certain Java library, in which case I can print out a data set directly to a tab file. So this is a tab separated file of the sort that can be read by Excel. And it requires this small bit of line for the code, which I explain here. Basically, you can give it a name and path of a file, and then you have a dataset name, and you can just say dataset name to string, and then print it out to this file, and that will create within the file a representation of all the data in the dataset. Okay, so it'll print out the contents of that dataset. And as I suggest here, the best place to put that is in the destroy code associated with a model. Okay. Alternatively, you could put it. Have separate invocations to output to the file associated with an event. Outputting to databases. I'm not going to talk much about this. Andre talked more about it. AnyLogic does provide these database interfaces here through these components. You'll notice that some of them are only available in some versions of AnyLogic. We have created our own little database interfaces that I'm glad to share with anyone. It's a very small bit of code that you can use to output to an SQL database. This database on the lower side could be as simple as H2 or Microsoft Access. On the upper side, it could be databases like Postgres, SQL Server by Microsoft, Oracle, or DB2 by IBM. Output to databases has a bunch of advantages. It's more flexible than string outputs to files. You can query it from diverse tools, including R, SPSS, SAS, etc., from Excel. You can easily clean it up. You can delete whole series of rows at once. For example, if you discover they were written out using an erroneous model or a version of the model that's no longer of interest. And for larger databases, for more robust databases, these things can be transactional. What I mean by that is it either is entirely output to the database or not at all. The cons of this is there's slightly more programming, and you need to set up a database structure. You need to set up a so-called schema on a database, which basically means defining the fields, the tables associated with the database, their associated the fields, their data types, etc. In general, there's some good practices for building databases for use with SQL. There's a notion of normalization, etc., that I don't have time to get into. But suffice it to say that these mechanisms from AnyLogic, if you use its built-in mechanisms for more advanced versions of AnyLogic, such as Professional, or if you use the sort of interface that I'm glad to provide, you can have quite sophisticated databases set up, or very simple databases. You can kind of choose how far you want to go down that road. With very sophisticated databases, you could set up things like indices, which will help it run faster. You could do query optimization. However, for the most part, you're not going to need to do that for most needs. Databases are extremely flexible and can really persist your data in a more reliable form than can files. If you output to files, one of the things you'll be finding is that you start getting all sorts of files littering your disk. You have to be very careful about naming them appropriately and documenting what they're actually showing. If you have metadata, often that goes in a header at the beginning of the file, and it can be awkward to process that. It can be more effective to put this information in a database, particularly in a so-called normalized form. So you have a set of scenarios with their parameter values in one table, and then you have data output from those scenarios in another table. What you have to be very careful about is choosing what to output. We do a huge amount of work output to databases, and one of the things you discover early on is that the databases can fill up very quickly if you're outputting things many times during the simulation. So you want to be very careful about how many values you output during a simulation if you're going to do that at all, and you may be better off outputting things at the end of a simulation. So I provide some prescriptions here for this. There's a one-time process of installing a database on a computer and adding reference to database libraries, and really there's setting up the database schema. So that's a definition of the fields, etc. And then for each time during the simulation, or maybe for the end time only, you want to open a database connection. You insert perhaps appropriate data, and then periodically during the simulation. So this is each scenario during simulation. And then periodically during simulation, you insert values, and at the end of the model execution, you close the database connection. So there's a set of databases that are oriented towards single users, others towards multiple users and multiple computers. These are client-server databases. They are typically more robust. They ensure the data won't be half output in sort of a corrupted form. In other words, they're transactional. These databases over here are for personal use. They are less robust, so you can get data corruption more easily. On the other hand, they're lighter weight and they're easier to use. Particularly Access has a very simple interface to create a little Access database. How many people here have worked with SQL before? Okay, modest number. SQL is a language that's, for its basics, fairly accessible to people not from computer background. There's a fair number of people out there who know it, who have very different backgrounds, and it's an extremely useful language to know. And when you process data from simulations, doing so through SQL can be very handy for summarizing certain things, particularly used with tools like R or Excel or what have you. So for anyone who's interested in using our database interface, you could just put a appropriate reference to the appropriate jar file, and then you can call these database classes. These are some examples of the database classes we use. This is a method to do a query. This is a method to do an update to data in the database, and they're very simple things. All they do is they execute a query and return back. So it's a really minimal amount of code that you need. So you can declare a connection that's your own database, and then you can go and create SQL statements and evaluate them. You call the interface and you say, perform this SQL statement. So some suggestions: maintain metadata, be mindful of the performance and space burdens, don't store more than you have to, and you may want to drag data from the database. It was asked earlier about the Excel support for AnyLogic, and I mentioned that Excel does allow for interaction. AnyLogic allows for interactions with Excel spreadsheets. This Excel file mechanism right here, which you can add to your model, this has a variety of methods associated with it, and just to sort of show how you could use it here, you could do Excel file, and then you can call this create cell is used, as I understand it, to sort of create a cell that could then be, for example, written into. And there's a wide variety of different components here that allow you to output data into the model. You notice you can write a data set into the Excel file, so you can output an entire data set into the Excel file as specified by the data set. You have to specify a sheet number, so that would be the Excel supports multiple worksheets, so you're going to provide a sheet number as well as the row index and the column index associated with that. As Andre says, if you're going to be writing to certain cells, you may have to create them first to make sure that you can write to them properly. I wish I had time to go into this more, but the Excel interface is very helpful for being able to create Excel spreadsheets. Alternatively, you can create text files of the sort we've seen, either through the built-in text file interface or through this custom code I gave you as part of this presentation. And you can use that to output a text file, which could then be read by Excel. Okay, so those are some comments on data here and use of it. A text file can be used to read in data, and the Excel file can be used to read in data, and the database interface can be used to read in data as well. So if you have, for example, exogenous variables in your model, which you need to have read in data, you can do so through those sort of interfaces and thereby drive the model with some fixed data over time. For example, immigration rates over time could drive the model. And you could use, for example, dynamic events to turn them into particular creation of individuals through the year. Okay, so those are some questions on outputting. Are there any questions on that? Yes? Right. Um, so if I understand you correctly, I think what you're asking is, as a convenience mechanism, is there some way to kind of have the parameters defined almost en masse or in a block in a way that could be output in a single statement, like put these in the Excel file, and then or do you have to do it one by one? So I would do it one by one, but I create a function to do that, and then I call the function. I mean, that's probably what you're thinking about doing, but I'm not sure that the need to handle them one by one can be avoided one or the other. In other words, conceivably I could put them into a data set and then output the data set to Excel, but even there I'd have to one by one add them to the data set. So I think any way you deal with it, you're probably going to have to specify what you want to output one by one. Right. Not that I'm aware of. I know exactly what you mean. And this is a hugely important thing to document the assumptions for your model, the parameters that main gas. In other words, what are the assumptions you're running this model with? You'd also want to output the model version number so that you know this was run with this version. You probably want to keep on incrementing the version. But I'm not aware of any way to sort of automatically do that. It would be nice. We commonly output that data to a database, but it does require explicit and ad hoc specifications. So if we forgot to include one of those parameters when we output it, there'd be no guard against that. We have to, it's by convention, and that's fragile, it's brittle. And I think that's what you're highlighting. Yeah, I'm not aware of any way of doing that automatically. It could be a wonderful feature if somehow AnyLogic supported that. Well, okay, through reflection you could do it. You could use, and this gets into refined topics. So one of the side effects of using Java, I mentioned this on the first day. One of the side effects of using Java is a lot of great functionality can come along with it. One of the advanced topics that would normally only be taught to people in third or fourth year computer science would be a thing called reflection, and that allows a Java program to ask itself, like, it's kind of make itself aware. What are my parameters? And it actually could go and it could get a list of its own parameters. We've used that with AnyLogic models before. And actually one thing you can do is you can go and get them, and then you can tell it through reflection to change them, which is an interesting thing. But reflection would allow you to do that, and that could allow a general purpose bit of code that you could take from model to model to model. You wouldn't have to modify it for each model. All it would do is placed in a given model, its job in life would be to take whatever parameters there are and output them. And that would be a nice piece of code. And that might be a piece of code I'd be fun to write. So if you have some interest, maybe you want to talk. Maybe I'll write something like that. And that. That would be a good thing. That would be very nice. Oh, it does. Yeah. Yeah. Yeah, the database interface in particular for the professional edition, that's really where you can use the database objects, which will simplify things quite a bit in interfacing with databases. There are a wide variety of other advantages that are conferred by use of the professional edition. They include the use of built-in debugger, which is also supported by the researcher edition. There's also the capacity to use custom experiments, which Andre demonstrated yesterday. They're great use. There's a number of other libraries that are also available in the professional edition. I haven't tracked the exact availability of each. Andre could tell you more, but I think there's certain GIS functionality, for example, which is very valuable. And in general, the professional edition allows you to export applications. So you can export so-called applets from these versions that we commonly use. But if you want to export Java applications, or if you want to call off to your model from another application, it's easier to do it through the professional edition. So there's a lot of extra things, but generally speaking, if you're willing to work with workarounds, you can often get by. It's more sort of work involved to do some of the same things with other versions, but generally you can do it. So, for example, I'll show, give a glimpse of how an external debugger can be used with it, etc. So, is that a helpful comment? Yeah, I mean, Andre could tell you much more about the different versions. Okay, things are getting tight for lunch. Any questions further? Questions? Okay. Sorry? Yeah. Yes, you can. There's two different levels to which that could be the case. The answer is yes, and we have models which do exactly that. So they read in the population as of the initial conditions, and they go through and set someone's characteristics. Now, I think you'll appreciate from our discussion that there's certain parts of that should be quite straightforward to you. So, for example, setting everyone's initial parameter values. That would be, we've seen how those can be drawn from a distribution, and you could just as readily draw them from a database or draw them from a so-called array or collection that's read in from a database. So I think you appreciate how parameters can be set. What's more tricky, you might think, is how you could set their state, like their initial state. Like this person is initially hospitalized, this other person is in a care home, this other person is at home, or something along those lines. So suppose they're in a state chart, and it turns out that one way to do that is when you come into a state chart, you could have a branch, one of those branches, and they'll go either to this initial state or that one, and so you could route them to different states based on some parameter you specify. So you have a parameter which specifies what state they should be in with respect to the activities of daily living status, what state they should be in with respect to chronic disease A, chronic disease B, and it would put them in the appropriate state from that. So that, it turns out that can be readily done. Now there's a whole other level of sophistication, which I'm not going to talk in detail about. There's a thing called a snapshot, okay? And AnyLogic Professional Edition supports ways of saving away a model state as a binary object, as sort of a monolithic object, and then reading it in and sort of freeze drawing it and then reconstituting it, for example, and restarting it or something along those lines. And so you can work with snapshots which provide a complete specification. I think that's fair to say, of model state, and you could then persist that and load it back in, something along those lines. I haven't worked with snapshots before, at least not for years, and Andre would be someone who could tell you more about that. But they provide a way of sort of saving away the information in the model, much as VDF files do in Benson, if anyone's familiar. They save away a sort of model's execution over time. This would be a way of saving away the state of the model. Is that okay? Yeah. Helpful? Other questions? Okay. I think we're good for time. Okay, very good. So I think we'll break then for an hour.
Yeah. Oh, wow. Okay.
Very nice. Very nice.
I think, when you get an overall prize, I'll trade it in. You and Andre might join together.